Hey devs, welcome back. Today we're here to go through the basics of React Native. This video is for you if you already have some knowledge from React and you're a beginner in the React Native world. Everything I show you here is based on my own experience working with React Native, focusing on what actually matters early on. If you feel like I'm missing something important, feel free to leave it in the comments. I'd love to hear your take on this. So I'm gonna show you some core concepts so you can get started. This is not a full app tutorial, we're not diving into deep architecture. We're gonna touch some basic concepts so that you can get started in exploring React Native and its applications. So I have prepared here a demo application so that we can take a look at the behavior of the things we're going to learn here. Before moving forward, I'd like to make a pause here to make a comment, and it's that I'm not an expert content creator, I'm not an expert teacher or professor, I'm just a software developer that is trying to share some knowledge so that others can learn new things and grow in their paths. So if you find any suggestions or any comments that you would like to make on the way I teach things or the way I make the videos, those comments are more than welcome and are more than useful so that I can keep making better content. That said, let's move on. But before we jump into the app, the first core concept that you need to understand is that though it uses the same language for programming, behind the scenes it doesn't work the same way. There is no DOM, no div, no CSS. Though it seems to, styling here happens with JavaScript objects using a native layout engine, and every component maps to a native view to each corresponding platform. For example, view component is not a div. It behaves similar, but it translates to native layouts, not to a div. Text, for example, you can't render it without wrapping it between two text tags. And navigation also happens with screens, not with pages. So as you can see here, there are several differences on how React Native behaves behind the scenes compared to React on web environments. So let's jump into the first section we're going to take a look at, which is the components demo. Here I have prepared some boxes or some sections with each of the components that we will go through, starting with the view component. So, as it says here, Vue is the most fundamental component for building UI. It's a container that supports layout with Flexbox style, touch handling, and accessibility controls. So basically, Vue is the main content wrapper that you'll find between applications. Basically contains your screen body. You can have as many as you want, as you can see here, and you can customize their style. You can add borders, background color, you can touch the flex direction, and so on. It works like this. You specify the two view tags, and inside you can have all the content that you want. In this case, we have some texts that describe the functionality of the views, and we also have another view inside the view. That's because you can have nested views. That doesn't matter. You can have as many views as you want. Think of them like if they were boxes, or think of them as if they were. They are not, but think of them as if they were divs in HTML. But like I said, the difference here is that they don't translate into divs. They translate into native components on each platform, on iOS and on Android. They are not divs, but they work or they behave similar to them. So you can wrap your content with views. Next component is the text component. Text is used to display text, basically. It supports nesting, styling, and touch handling. All text in React Native must be inside a text component. This means that you can't render text without wrapping it between two text tags, or the application will break, as you can see here. Text without tags. If I say this, I will have an error here. So we also said that it supports the touch handling. So if I tap on here, I have this alert, or you can take the action you want here, specified with the onPress property. So you will need the text tag every time you want to render some text, because otherwise you will get errors. It just simply works like this. You wrap the text that you want to write between text tags, and you can specify some styling, and some other properties like the onPress, for example. Third component, the touchable opacity component. This one over here, touchable opacity. The touchable opacity is a wrapper that makes views respond properly to touches. We said that the view can respond to touch events, so the touchable opacity is a wrapper for the views that makes the views respond properly to touches. On press down, the opacity of the wrapped view is decreased, as you can see here with the example. When I press, okay, that doesn't happen because I was playing around here with the active opacity. This is a property that you can set up so that you can modify how strong is this decreasing of the opacity of the touchable when you press on it. So for example, right now it's set to 1, so that means that when I press on the bottom, the opacity will be 1. But if I say here, for example, 0, it will completely disappear and appear again, so that it gives the user some feedback that the button is getting touched. Then default value here, I think it is 0.0. Oh, 0.2 is the default value, as we can see. So we save, and this is the default appearance that we have when we tap on these buttons. So we can play around with this one. For example, I like the 0.7, which is smoother. So touchable opacity. This is a tag, and you put inside the content that you want to render. You can place views here inside, you can place icons, you can place whatever you want to react to press actions. Then we have the button component over here. This is also a component that reacts to touch events, but in this case, this is less used through React Native applications because the styling is more limited. As you can see, we set the color here and the title, but with the touchable opacity, we can set directly a style and style the component however we want. We can add the stylings we want. We can also play around with the flex direction, with the background color, with the borders, with whatever we want. The button has styling more limited, so the touchable opacity is the component that is more used through React Native applications. So as you can see here, button is a basic button component that should render nicely on any platform. It's a part, a minimal level of customization, and the times it was pressed here, as you can see. Then the image component. Basically, image is used to display images. It supports local images with require and remote images with URI or URLs. So the image, we have the resize mode, which is like the object fit property in CSS in web development. We can apply some styling also here, and the source can be specified either with require when we have the local asset, or with this URI when we have a remote asset. So if I say here, we have this remote image taken by the URL. So at this point, I hope you already noticed that we are wrapping every section in a view component, because like we already saw, the view is the main content wrapper that you will find in the applications. It's the boxes that you will find out there. And then we also have all the text wrapped in text components. So I hope at this point that's super clear. So that was the image tag or the image component. Next one is the text input component. If you've worked with React, you might be wondering how you can handle forms in React Native. Well, that is where the text input appears. You can also handle the change actions with the onChange text so that you can have a controlled form with the state. You can customize the placeholder text color. You can set the placeholder. You can add some styling also. And here goes the value that you will handle with the state variable. That's pretty much what we have with the text input components. Pretty similar to what we have in web development. Like I said, you can work with controlled forms with state variables here. So next one will remain here in the text input, because the next one is the keyboard awaiting view. And the keyboard awaiting view automatically adjusts its height, position, or button padding based on the keyboard height to remain visible while the virtual keyboard is displayed. The entire screen is wrapped in a keyboard awaiting view. So if you noticed here, like it says, the entire screen is wrapped in a keyboard awaiting view. And what is this for? This is mainly used for the forms. When we have, for example, a text input here and it's placed at the bottom of the screen and you want to type something, the keyboard will get opened, and we want to make sure that the text input is not overlapped by the keyboard so that we can see what we are typing it, okay? So let's suppose, for example, that we replace the keyboard awaiting view with just a view. Behind the scenes, the keyboard awaiting view is also a view, but with extended features. The main feature it has is that it makes sure that we scroll the screen when we are typing in a text input that relies on the bottom of the screen. But if we replace this with the view component, you will see that the behavior here is not the same. Now, if I try to type here, it falls behind the keyboard and we can't see what we're typing it. So this is super important for a good user experience. So returning this back to a keyboard awaiting view, saving. If we scroll down, you will notice that it adjusts the height of the screen, the position of the text input, and we can type safely now. So there's nothing new here. We have just view and text explaining what the keyboard awaiting view does, because the keyboard awaiting view must wrap the content of the screen so that it can calculate properly the adjustment of the position when scrolling up. Then the next component is the scroll view. Also, if you noticed, the scroll view is wrapping the entire screen, and it's pretty much another, well, like it says here, scroll view is a generic scrolling container that can contain multiple components and views. This entire content is inside a scroll view, allowing you to scroll through all the examples. So, like I said, if you noticed, the screen is also wrapped after the keyboard awaiting view, which is wrapping everything, is wrapped with the scroll view. This is wrapping everything. And that's because we want to scroll through the content we have in this screen. So wrapping everything with the scroll view makes the whole screen scrollable. We can also customize the scroll view and the content inside the scroll view with some styling that we'll see later. Then the last component that we have here is the FlatList component, which is a performant interface for rendering simple FlatList, supporting the most handy features: pulse, refresh, header, footer components, separator components, and more. It's optimized for long lists of data. So it's also similar to the scroll view because it allows us to scroll through the content that we have on the screen, but it's pretty much intended for the lists of items when we have repeated lists of items. Scroll view is mostly for screen content, general screen content, but then if we have some items that we need to scroll through, we should use the FlatList component. This component also allows us to use this pulse refresh feature. As you can see here, that's the pulse refresh. When we reach the top of the list and we keep scrolling, it makes this action, like if it's reloading something. So that's super useful when we are working with remote data, when we need to fetch data from our API. We just pulse refresh, it makes the request to the API, and we receive the data back on the application, and we update the list of items. In order to use that, we need to pass a property to this FlatList component, which is the onRefresh. We just used here a state value, a Boolean state value. We set it to true, set refreshing, and that refreshing state value, we pass it here. So refreshing, when it's refreshing, when the value of refreshing is true, we'll see that wheel spinning on the top of the list. Then we show that alert indicating that we're refreshing, and after some timeout we just set the refreshing to false, and it removes the spinning wheel over here. So at first glance, scroll view and FlatList look similar. They both let you scroll through content, but the difference is how they work. Scroll view renders everything at once. That means that all items are mounted in memory, even the ones that you can see in the screen. This is fine for small content like a setting, screen, or a form. But FlatList, on the other hand, is optimized for large lists. It only renders the items that are currently on the screen visible and reuses them as you scroll. This makes a huge difference for performance when you have long lists of data. So a good rule of thumb is, if you're rendering a list of items, use FlatList. If you're rendering a small scrollable layout, use scroll view. So these are some of the most used components through React Native applications. The crucial ones, I would say, are the scroll view, the FlatList, the view, of course, the text, and the touchable opacity component. So grab that in your mind because you will find those components in all the React Native applications. They are super crucial when working with React Native. Scroll view, FlatList, view, text, and touchable opacity. Of course, you'll find the other ones, but the most crucial are the ones I mentioned to you. So the next thing we're going to see is the styling. This is where most beginners struggle, and the reason is simple. React Native uses Flexbox by default, but unlike the web, the default direction is column, not row. Layout is controlled mainly, in most of the cases, using Flex, justify content, and align items, as you can see here. In this case, the direction is modified specifying the Flex direction row, because like I said, the default direction is column. Flexbox is always enabled, and the default direction is column. Styles also are written as JavaScript objects, as you can see here, and usually grouped using the stylesheet.create. This gives us validation, better performance, and cleaner code. It helps us because, for example, when we want to type some properties, I can type a letter here and we get a lot of hints. And that's because we were wrapping the styles inside the stylesheet create, which, like I said, gives us some validation. Stylesheet create freezes the styles, validates them, and makes them more efficient internally. It also makes your code cleaner and easier to maintain. Inline styles are fine for quick experiments or very small components, but for real screens, you should prefer using stylesheet create. So the way this works is that you create the name of the styling, you apply some stylings, and then, for example, in the places that you want to apply this specific style, you just copy the name, you go to the component where you want to apply this. In this case, is the container, so we set up the style, and we call the styles variable and the container property, because at the end, this is a JavaScript object, but that has some validation thanks to this stylesheet create. The same with the section, for example. We're calling here the styles.section. In every place we want to use this styling, you can think of this like if it was similar to the classes in HTML, but it's just calling a JavaScript object and the property section, which name we are choosing. So that's it about components and styling. The next important thing that we're going to talk about is the safe area view, or the safe area of the screen where we want to draw our content. Mobile screens are not all the same. They have notches, status bars, and different sizes, and your UI can easily end up hidden if you are not careful. That's why safe area view component exists. It keeps your content inside the visible area of the screen. If I remove it, for example, and change it with view, you will see that the content gets overlapped by the notch and by the status bar. So we don't want that in our applications because that's not a good user experience or user interface. So with the safe area view, we make sure this doesn't happen. Also, the status bar behaves differently across devices. Sometimes it has different heights, so hard coding positions at the top is a common mistake. Try to avoid using that and try to use the safe area view. Because another beginner trap is using fixed heights. They might look fine on your phone, but they break on others. Instead, rely on Flexbox and flexible layouts. So far, we've been working with individual screens, but the next question is, how do we move from one screen to another? In a mobile app, you usually have more than one screen. You might have a home screen, a detail screen, a profile screen, and so on. In this example, we have the home screen, the components demo screen, the navigation demo screen, and the safe area view demo screen. These are all different screens and we are navigating through them. So there needs to be a system that decides which screen is visible and how we move between screens and how we go back. React Native doesn't include this system by default. Expo Router is a tool that helps us organize and move between screens. Instead of manually configuring navigation in a lot of code, Expo Router uses your folder structure. Each screen is a file. Each folder groups related screens together. When you create a new screen file, it automatically becomes part of the app. This approach removes a lot of setup. You don't have to register screens manually, you don't have to worry about wiring everything together. You focus on building screens, and Expo Router handles how they connect. The only thing that you need to set up is the stack component that you imported from the Expo Router library. You can set up here some screen options like header shown, true or false. This indicates if we are showing or hiding the header, as you saw there. Then the style, for example, you can set up here some header color, the background color, the tint color, for example, also here. Some styling to the title of the header. So that goes inside the stack component that comes from Expo Router. Then inside the stack components, you will add all the screens that you want to render, and you do it with the stack.screen component, setting up the name of the screen and the options like the title or if the back button is visible or not. The important thing here is that the name of the screen must match the name of the file you are creating. So the components demo screen, this one over here, should match the components demo file name. The same with the navigation demo that matches the navigation demo file name, and the SafeArea demo that also matches the SafeArea demo file. That's the way we indicate the navigation system, what are the screens that we want to render or what are the files that contain our screens. So even though Expo Router feels simple, there is still a navigation system doing the real work. Expo Router doesn't invent navigation from scratch. It uses an existing navigation engine that handles screen transitions, gestures, and navigation history. You don't need to know that engine yet, just know that it exists and it's very stable. So as you can see here, we have the layout TSX. This file defines how a group of screens is connected. Like I said, we have the stack and we have the screens inside the stack. So in this case, these screens belong to the same stack. So think of this layout file as the place where we specify the structure of our application, not the content. The content goes inside the screens, inside these files. So the most important thing here is that these ideas of the navigation are not Expo only. Screens, navigation, going forward and going back exist in every React Native app. Expo Router just gives us a friendly way to start so that we don't need to configure everything in our own and write a lot of code. Later, when you go deeper into React Native, you'll discover that Expo Router is built on top of a very popular navigation library. This library I've been talking about is React Navigation. That's good news because it means what you learn here will still apply when your app gets bigger. Expo Router lets you focus on screens first. The navigation system grows with you as you learn more. Now that we understand how screens connect, let's look at navigation in action. Now that we are here inside the navigation demo screen, we go to the navigation demo file, which is specified here, navigation demo. Remember that it must match the same name of the file of the screen we want to implement. Navigation demo, we have this screen. And the way we get into this screen is by using the Expo Router with this action over here, router push, and the name of the screen, the name of the file where we want to navigate. So for example, in the index case, which is, if we go back to the layout and take a look over here, the home screen that we have here is set up in the index file, and we have the index name of the route and the index name in the file. If we go inside the index file, we have the content of this home screen. And the way we are navigating to the components demo, the navigation demo, and the SafeArea view demo is using the router push and the path to the file. So in the case of the navigation demo that we'll learn over here, we use the touchable opacity to handle the touch event, and on the onPress function, we pass a function that calls this router push and the path to the route, which in this case is navigation demo that matches the name of the file. So we go inside this screen and we go inside this file. Then here we have several actions that can be taken. The router push, use router hook, link component, router back, which is for going back, and router replace. And we have also something useful here, which is the navigation history. Some best practices: use link for declarative navigation in JSX, use router push for programmatic navigation, router replace when you don't want back navigation, always provide a way back, and use type routes for better TypeScript support. So if we go to the router push, this could be probably the most common usage of the router navigation. Actually, the router push and the router going back, which is actioned with the router back. So router back and router push could be probably the most common functions used from Expo Router. Basically, router push and the path to the route. If we check the usage of this function over here, it's wrapped again in a touchable opacity, which will handle the onPress event, and we're passing to this function the path to the components demo screen. So when we tap on this button that says navigate to components demo, which is the text over here, when we tap on this, we'll navigate to the components demo screen. And here we have the code that goes behind the scenes inside this function. Router push and the path that we're passing through params, which is components demo. So when tapping on this button, we'll go to the components demo screen, because we are calling router push and the path to components demo screen. Then the back navigation here is handled automatically by the Expo Router system, better said by the React navigation system, because the header comes by default. We can customize and make some things over here, but by default it's handled by the back component over here. That we can do that manually using the, like I told you, the router back. We can do that manually also when we want to navigate back from different places that are not the header. So second thing we find over here is the use router hook. The use router hook provides the same navigation methods, but you can use it in any component within the router component. So basically it's a hook that you import from Expo Router, you call it whatever you want, and use the router hook and push also. So it provides us with the same functions that we have in the default router that comes from Expo Router. It's just an alternative that we can use in all the components that we want. So same case here, router hook, push, and we're going here. Let me check the route where we are going. We're going here also to the components demo screen. So navigate using the use router hook and then going back to the previous screen. Third thing we find over here is the link component. So link component is a more explicit way to navigate to other screens, and it provides better accessibility and web support, but it's pretty much the same. It navigates to the route when it's pressed, and the route where we want to navigate is indicated over here with the href, like if it was an anchor component in web development. And we specify here the path to our route. Then we have inside also the touchable opacity, but this is set up only to add the history to the navigation. This doesn't have anything to do with the navigation to the screen. The navigation is handled only by the link component in this case. So we're also going here to the components demo. Then what happens here, for example, if we change this and instead of going to the components demo, we go to the save area demo. We can do that. Save area demo. We save, and once we navigate over here, we're going to the save area view demo. So that simply we can navigate to different screens, specifying just the path to the file where we want to navigate. Then the fourth item here is the router back. I already told you about this one. It's the function we use for going back. So in the touchable opacity here, we're just handling the onPress function with the go back function over here, and it just uses router back, and it takes us to the previous screen that we were before. Go back, it takes us to the home screen. So inside navigation demo again, the last item we have is the router replace, and the difference here is that it replaces the current route with a new one. The user cannot go back to the previous screen using the back button. The main difference here is that the router push places a new screen on top of the navigation history. It places a new screen on top, like you can see here. If we go back, we have the other screen behind. And the difference with the router replace is that it doesn't place a new screen on top. It just basically replaces the screen we are right now. So replace with components demo will completely replace the screen, and now if we go back, we're going back to the home screen, and that happens because we are replacing the screen. So again, router push places a new screen on top, and if we go back, we go back to navigation demo, and again we're going to the home screen. But then instead of putting a new screen on top, we just replace the current screen. When we go back, we'll go back to the home screen instead. So that's pretty much all we have regarding navigation. We have also the navigation history here, which is probably a useful feature, but don't pay much attention to that yet. We're just adding some history here when navigating, and when we go back, we can check the navigation history, and we have that we pushed a new route, but that doesn't matter right now. You just Just keep in your mind that you can store the navigation history, but don't pay much attention to that yet. So with these two things, components and navigation, we have covered pretty much the core of React Native applications. You will find components and navigation in every single app of React Native. The components I showed you are the most common components you will find out there, and the navigation system with Expo Router is a new standard or the new recommended system by the React Native team, because it encourages now developers to use Expo as the default framework for new applications. And the functions I showed you, the router push, the router replace, the router back, and the use router hook, for example, are the most commonly used functions when you're working with routers. So the next thing we can talk about is hooks in a mobile context. And hooks in React Native work the same way they do in React for the web. Use state manages state, use effect runs side effects, but the difference isn't the hooks themselves, it's the environment. On mobile, screens mount and unmount more often, so effects usually run when a screen appears and clean up when you leave. I mean, this action, it's mounting and then it's unmounting. That's why you'll often see effects used for things like data fetching or setting up listeners. Sometimes you want logic to run when a screen becomes visible again, like in this case, or when going back, for example, the home screen gets visible again, and there are hooks for that, but you don't need them yet. For now, focus on clarity. Don't worry about use memo or use callback. Don't optimize what you don't understand yet. So at this point, you already know enough React Native to start building real screens. Start slowly, start with components, start dominating navigation. If you feel curious, also you can start taking a look to React navigation library instead of using Expo Router, but that's a bit more complicated. But you don't need Redux, complex architecture, or advanced optimizations yet. First, dominate the basics and then start learning more. What you need next is practice, building layouts with the views components, handling user inputs, using also the keyboard operating view so that we get a good user experience, and navigating between screens. Take this demo application, change it, break it, play around with the components, play around with the navigation, read the code so that you understand really what's going on, rebuild it if you want, and that's how React Native really clicks, with practice, with working with it. Build something small, and if you get stuck, leave a comment. I read them all. And if you want to keep learning together, subscribe for more React Native content like this. Feel free and more than invited to leave a comment in this video if you liked it, if it was useful for you, and if you want to receive more React Native or more React tutorials in the future. That's all from my side for now, and I'll see you in the next one.